Assalamu alaikum, dear students. Today our topic is osmotic pressure. It is four colligative property. And before discussing the osmotic pressure and deriving the expression for it, we must know what is osmosis. So we will first discuss what is osmosis. For the explanation of the osmosis, we will perform a simple experiment. We will take a beaker and we will divide this beaker by a semi-permeable membrane. What is a semi-permeable membrane? It is a membrane which allows solvent molecules to pass through. But not bigger molecules like solute particles. For example, cellophane, parchment paper, pig bladder, or goat bladder. What is semi-permeable membrane? It is a membrane which allows solvent molecules to pass through, but not bigger molecules like solute particles, cellophane, parchment paper, pig bladder, goat bladder, copper ferrocyanide. These are the examples of the semi-permeable membrane. These appear to be like thin sheets or the films which possess submicroscopic pores or the holes. Now we divide this beaker by this semi-permeable membrane into two components. In the one component we will take solution of copper sulfate, which is blue in color, and in another compartment we will take water, which is solvent. After some time, कुछ मुद्दत के बाद, we see the level on the solution side rises. This is because the water or the solvent molecules flow through the semi-permeable membrane, due to which the level of the solution rises. This movement of the particles, solvent particles, is called osmosis. So the level, when the water passes into it, the level in the solution increases like this, and level on the solvent side, water side, it decreases. Similar type of movement is seen, the flow of the solvent particles is seen if we take a solution, two solutions, we separate the two same solutions, one concentrated and another dilute. Suppose we will take copper sulfate concentrated solution, and we will take dilute copper sulfate solution, dilute copper sulfate. And in the two compartments of the beaker, which is divided by the semi-permeable membrane, here we also see that the movement of the solvent molecules from lesser concentrated solution, that is dilute copper sulfate, into the more concentrated copper sulfate solution. So What is osmosis? Osmosis is the process of flow of solvent molecules from solvent into the solution or from less dilute solution into more less dilute, less concentrated solution into more concentrated solution. So this is osmosis. Now we can demonstrate this osmosis in the laboratory by taking two eggs. We take two eggs of similar size. We dissolve the eggs in the dilute sulfuric solution. The outer shell of the eggs consists of calcium carbonate. So when we dissolve it in a dilute sulfuric acid, this calcium carbonate gets dissolved in it, and the outer soft semi-permeable membrane of the egg retains there. Now we will take one egg and put it into water. एक एग को हम वाटर में डालेंगे और दूसरा एग जो है वो एक बीकर में ले लेंगे जिसमें हम ब्राइन सॉल्यूशन ले लेंगे. Now what is brine? It is a solution of the sodium chloride, salt solution. What do we see? In the first case, the water molecules pass into this egg, which contains concentrated fluid, through the outer walls which act as semi-permeable membrane. So the egg in the water, it swells. And in the second case, the water in the fluid comes out of the egg and passes into the sodium chloride solution, into the brine solution, because through osmosis, because this is more concentrated, and due to the osmosis the water in the fluid passes out of the egg. Therefore this egg shrinks. This is the example of osmosis in the egg, in which one egg swells and another shrinks due to the osmosis. Here the osmosis of the water, in the first case osmosis of water into the egg takes place, and in another case the osmosis of the water from the concentrated fluid takes place into the sodium chloride solution. Now this is all about osmosis. Now we will explain what is osmotic pressure. तो osmotic pressure explain करने के लिए again we will perform the experiment, and we will take inverted thistle funnel, the mouth of which is tied by a semi-permeable membrane. This is semi-permeable membrane like cellophane, or we tie it with pig bladder. And उसके बाद we take a solution. इसमें हम solution ले लेंगे. Say we take sugar solution. शुगर सोल्यूशन हम इस इन्वर्टेड थेसल फेनल में ले लेंगे, और इस थेसल फेनल को हम एक बीकर में डालेंगे which contains the water. This is the initial state. इनिशियल स्टेट ये हम ले लेंगे. तो जब हमने इस sugar solution which is in the thistle funnel, inverted thistle funnel, which is tied by a semi-permeable membrane, put in the beaker containing the water, the osmosis of the water takes place and the water pass into the solution. Due to the osmosis, the level of the solution in the, this is initial, ये initial state में है, ये level है, this is the level sugar solution in this thistle funnel. और जब osmosis होती है, the solvent molecules pass into the water molecules pass into through semi-permeable membrane इस thistle funnel में, and the level of this solution in the thistle funnel increases. So at this stage, the additional hydrostatic pressure is created on the solution. Now, when the water passes into it, a stage reaches when the level of the solution remains the constant. तो क्या होता है? At this stage, the hydrostatic pressure is just sufficient to prevent the further flow or entry of the solvent molecules into the solution. क्योंकि यहाँ से ये water है, ये this is sugar solution, this is the sugar made in water, so this is sugar. तो solvent molecules, water molecules इसमें due to the osmosis enter होते हैं और इस solution की level बढ़ जाती है. जब ये बढ़ जाती है तो आहिस्ता आहिस्ता से हाइड्रोस्टेटिक प्रेशर भी बढ़ जाता है. स्टेज रीचेस व्हेन द लेवल रिमेन्स कांस्टेंट. At this stage, the hydrostatic pressure is sufficient to prevent the further inflow of the water into the solution. This equilibrium hydrostatic pressure, which is sufficient to prevent the flow of the water into the solvent into the solution, is called osmotic pressure. Thus, the equilibrium hydrostatic pressure on the solution required, which is required to prevent the flow of solvent into solution, is called osmotic pressure. तो वो हाइड्रोस्टेटिक प्रेशर जो इस सॉल्यूशन पे अटेन हो गया और जिसने सॉल्वेंट मॉलिक्यूल्स की एंट्री रेस्ट्रिक्ट कर दी, स्टॉप कर दी, दिस प्रेशर इज हाइड्रोस्टेटिक प्रेशर इज कॉल्ड द ऑस्मोटिक प्रेशर. डियर स्टूडेंट्स, यहाँ एक बात बहुत ज़रूरी आपको याद रखनी है. When we take the solution as such separately, we take it as vapor pressure. But when we take the solution and separate it from the solvent by a semi-permeable membrane, there we note it is osmotic pressure. So this is osmotic pressure. Alternately, we can also explain this osmotic pressure if we take a vessel. In the vessel, we divide it by a semi-permeable membrane and we divide it into the two components by the semi-permeable membrane, and one component we fit a narrow tube which contains solvent, and another compartment we fill with the solution, and at the top it is fitted with a wide tube. This is a wide tube, and it is fitted with piston. What happens? Due to the osmosis, the solvent molecules tend to pass. They pass through the semi-permeable membrane into the solution. As a result, the solution will tend to push the piston outside, and that is observed that the level in the narrow tube of the solvent that falls. Now, अब हम क्या करते हैं? We apply the external pressure. The pressure हम पिस्टन के जरिए से इस solution पे apply करते हैं ताकि we prevent the entry of the solvent into the solution. So the required pressure applied so as to prevent the entry of the solvent in the solution. How we can note that? By the level in the narrow tube, level of the solvent in the narrow tube, कि कितना प्रेशर हमें अप्लाई करना है ताकि ये लेवल जो है वो उतनी ही रह जाएगी जितनी हमें पहले हमने सॉल्वेंट की ले ली थी. Now this pressure applied on the solution is called, it measures the osmotic pressure. So the osmotic pressure is the pressure that is applied on the solution in order to prevent the entry of the solvent or the flow or the movement of the solvent molecules into the solution through this semi-permeable membrane. This was all about osmotic pressure. Now derivation of the equation for the osmotic pressure. Derivation of equation for or the expression for osmotic pressure. Expression Van 't Hoff made a thorough study of the osmotic pressure of dilute solutions or ideal solutions. He concluded that these solutions behave like ideal gases. What solutions? These dilute solutions or these ideal solutions, these behave like ideal gases, and different gas laws can be applied to these or applied to these solutions as well. On the basis of this, it was observed that osmotic pressure of a solution is directly proportional to molar concentration of the solution and its temperature. Now, on the basis of experience of the what Van 't Hooft has observed, he observed that the osmotic pressure of a solution is directly proportional to the molar concentration of the solution and its temperature. Mathematically, pi, we denote the osmotic pressure by pi, is directly proportional to C. This is the molar concentration, and pi is proportional to T, or pi is directly proportional to Ct, or pi is equal to RCT, where C molar concentration, T is the temperature, R is constant called solution constant, and its value has been found equal to Gauss constant. So in other words, we can say R is the Gauss constant. But C, the molar concentration, is also equal to N by V, where N is the number of moles of solute and V is the volume of solution in liters. So this equation becomes pi is equal to R, C की जगह N by V into T, or pi V is equal to N or T. This is the equation for the osmotic pressure. This is also called, this equation is also called Van 't Hooft equation. So we have the equation pi V is equal to N or T, where pi is the osmotic pressure, V is the volume of the solution in liters, N is the number of moles of the solute, R is the Gauss constant or the solution constant, T is the temperature of the solution. Now, determination of molar mass. From this osmotic pressure equation. Determination of molar mass of solute by osmotic pressure. Now we have the expression for the osmotic pressure. We know pi V is equal to N or T. If WB grams of the solute having molar mass MB is taken, then above equation becomes pi V is equal to N. For N we will write WB bata MB. Number of moles of the solute is equal to the mass of the solute divided by the molar mass of the solute. So we can write WB divided by MB into RT. So pi V is equal to WB RT divided by MB. Now we have to calculate the molar mass of the solute. So MB is equal to WB RT divided by pi into V. Thus knowing all the values for WB, RT, pi and V, the value of molar mass of solute can be determined. तो ये हमें इक्वेशन बन गई फॉर डिटरमाइनिंग द मोलर मास ऑफ द नॉन वोलेटाइल solute, which is equal to mass of the solute. R is the gas constant, solution constant, T is the absolute temperature, pi and this is V. Pause. तो मैं बोर्ड इस न्यूमेरिकल के लिए टर्न करूं. We have the numerical based on the osmotic pressure. The numerical is 200 centimeter cube of an aqueous solution of the protein contains 1.26 grams of the protein. We have a solution of the protein. It is the aqueous solution. That means our solvent is the water and the solute is the protein. The osmotic pressure of the solution at 300, the temperature of the solution is 300 Kelvin and the osmotic pressure is 2.57 into 10 raised power minus 3. The solution is equal to 200 centimeter cube. Now, volume is equal to 200 centimeter cube. इसको हम लीटर में कन्वर्ट करके 1000 से डिवाइड करेंगे. That will equal to 0.2 liter. By dividing, because 1000 centimeter cube is equal to 1 liter. So to convert the centimeter cube into liter, we divide it by 2000 here 1000. So 200 by 1000 means 0.2 liter or L. Again, we have R is equal to 8.314 joules. We convert, we know 100 joules is equal to liter 1 liter bar. So instead of joule we will write liter bar. So R is equal to, इसको 100 से डिवाइड करेंगे, that will be equal to 0.8134 liter bar per Kelvin per mole. So 8.314. We will take only up to the 2 place of decimal, that is approximately 0.83 liter bar per Kelvin per mole. And the osmotic pressure is equal to 2.57 into 10 raised power minus 3 bar. Now we have the equation that MB is equal to WBRT and pi V. Substitute the values. WB is equal to 1.26. WB is equal to 1.26 gram. So 1.26 gram into R is equal to 0.83 liter bar per Kelvin per mole into T 300 Kelvin divided by pi, the osmotic pressure, it is equal to 2.507 into 10 raised power minus 3 bar, and to V, the volume is equal to 0.2 liter. Now first we will determine the symbol. Liter cancel, bar cancel, Kelvin per Kelvin and Kelvin cancel. So we have only unit gram per mole. So this is 1.26. We will write 126 divided by 1000. Similarly, we have 2 place of the decimal, 2 digits on the right side of the decimal. Here too we have 2 digits on the right side of the decimal. So we will write 126 divided by 257. And it is 83 divided by 100 into 300 divided by, यहाँ रह गया 10 raised power minus 3 into 0.2 को हम 2 into 10 यहाँ पर ले लेंगे, 0.2 के बदले 2 by 10, 10 ऊपर ले लेंगे, यहाँ पर आएगा grams per mole. So on solving this we will get the value. आप कैलकुलेटर या आप सीधा ऐसा कर सकते हैं, 257 into 83, ये आएगा 10 raised power 3 माइनस ये 10 raised power 2, यहाँ 10 raised power minus 1 आएगा, ये 10 raised power minus 1 ऊपर चलेगा 100, that is 33, 10 ऊपर 300, 0 and 0 divided by 2. When we solve it, its value comes up out to be equal to 61038 grams per mole. This is the value of the molar mass of the solute, which is the protein. Thank you.